This presentation covers templates in C++. If you're reading through Chapter 13 of the Malik text, there's also some additional information on operator overloading, random numbers, and the this pointer. I'll cover those in a separate presentation since I think they distract from the main point. Algorithms can be more general than their parameters. For example, you probably wrote a function CS1 to swap values. Here's such a function that swaps a pair of integers. Note that the use of the reference parameters as well as the temporary storage value. We created that function to swap a pair of integer values. What if we wanted to use the code to swap values of type double? Well, one solution would be to duplicate the function using copy and paste. We could then replace the occurrences event with double. There are some problems with this. First, it's not elegant. Second, there's a lot of duplication of code. And third, we're going to run into trouble if we ever have to modify it since we'll have to fix every single occurrence. So what we really want is to just have one function definition and a generic variable type. This code has the right idea, but it's not quite to the level of official C++. In order to achieve algorithm abstraction in C++, we need a construct known as templates. Let's see how to make this happen. Here we see a C++ function template that will allow swap values to swap values of two values of the same type regardless of what type the variables are. Template class T is the template prefix. This tells the compiler that the declaration or definition that follows is a template, and lets the compiler know that T is a type parameter. Class in this context means type, and T can be replaced by any type. A template overloads the function name by replacing T with the type used in the function call, that is to say, the type of the actual parameters. Class refers to any built-in type for which the function makes sense. For example, multiplication makes sense for integers, but it might not make sense for strings. Calling a function defined with the template is identical to calling a normal function. The compiler checks the argument types and it generates the appropriate version of swap values. The function template may also have separate declarations. You'll need the template prefix and type parameter. Depending on your compiler, you may or may not be able to separate the declaration definition of the template functions in the same way that you do with regular functions. You may also need to include your template definition with the code that uses it. To be safe, place template function definitions in the same file where they are used and put the declaration definition together. You can also put them in a header file, since the file included with #include is, in most cases, equivalent to being in the same file. T is the traditional name for the type parameter, but you can use any valid non-keyword identifier. For example, variable type or VT, T1, T2, those would all work. Function templates can use more than one parameter with the caveat that all parameters must be used in the template function. Using template functions allows us to express more general algorithms in C++. Algorithm abstraction means expressing algorithms in a very general way so that we can ignore incidental detail. Algorithm abstraction allows us to concentrate on the substantive part of the algorithm. For example, we concentrate on the swap routine itself rather than on the types of variables that go into it. The sort function on this slide uses an algorithm that should not depend on the base type of the array. We'd like to use this to sort an array regardless of the type. Now it's important to note that this sort routine uses two helper functions. One is index of smallest and the other is swap values. In order to make a template for it, we need to template all three functions, and then we'll have our abstract implementation. In looking at this, the index of smallest compares the items in the array using the less than operator. If a template function uses an operator such as less than, then that operator must make sense for the types being compared. This generally means overloading the operator if we're using a class. When defining a template, it's a good idea to start with an ordinary function that accomplishes the task with a single type. You'll then want to debug the ordinary function and convert the function to a template by replacing type names with a type parameter. In other words, get something working and then modify it to be more generic. As a general life hint, it's often easier to deal with a concrete case rather than a general abstract one. Templates can be used for any type for which the code in the function makes sense. For example, swap values make sense for individual objects of a type such as cents or doubles. However, the assignment operator used in swap values would not work for entire arrays. Class definitions can also be made more general with templates. The syntax for class templates is basically the same as for function templates. Template class T comes before the template definition, and type parameter T is used in the class definition just like any other type, and the type parameter T can represent any single type. The pair class shown here is a class template. An object of this class contains a pair of values of type T. Once the class template is defined, objects may be declared as long as the declaration indicates what type is being used for T. For example, a pair could hold integers to reflect a score, or a pair of characters to indicate a seat in a theater. After a declaration, objects based on the template class are used just like any other objects. Member functions of a template class are defined the same way as member functions of ordinary classes. The only difference is that member function definitions are themselves templates. We need to indicate T in the class name before the scope resolution operator and then the function parameters. This is the definition of a constructor for class pair that takes two arguments. It's important to note that the class name includes T. The same thing that's true for the constructor function is true for member functions. We need to remember to include the template type with the class. If we're passing to an ordinary function, we need to include the type of the particular implementation we're using. Of course, function addup can be made more general by making it a template function itself. So at the end of the day, this may look pretty familiar. In fact, you've probably used a template class before, namely vector. Anyway, thanks for watching, and as always, be sure to check La Lima for assignments and more.